Hello, and welcome to GRC 605 Unit 5's presentation. My name is Lamont Bass, and today I will be covering the chi-square test of independence. Let's begin with our agenda. Number 1, we'll do an introduction. Number 2, we'll state the hypothesis, the rejection rule, and supporting details. Number 3, conduct the chi-square test using PSPP. Number 4, examine PSPP's output and relevant hypothesis test. Number 5, I will offer my takeaways from today's presentation, and I will close number 6. Introduction. We are tasked with conducting chi-square analysis tests and presenting the findings of 3 given datasets. Additionally, if we reject a null hypothesis when P is less than A, where A equals 0.05, we will follow with Kramer's V. We use the chi-square test of independence when you have 2 nominal variables and you want to see whether the proportions of one variable are different for different values of the other variable. We use the Kramer's V test as a way of calculating correlation in tables which have more than 2 by 2 rows and columns. It is used as a post-test to determine strengths of association after chi-square has determined significance. The dataset we'll be using today, the following dataset was generated using a SurveyMonkey survey asking 150 participants located in the Midwest questions regarding their income, debt, savings, and other important personal finance factors. For the first test, we'll be looking at num cars and num defaults. The second test, lick comfort and num defaults. And for the third and final test, num cars and lick comfort. Using PSPP software, we will undergo a series of 4 steps to conduct the chi-square test to find significance and follow up with APA write-ups. Step 1 of this process is to open PSPP and import the data. Step 2 is state the hypothesis. Step 3, conduct an independence test. And step 4, present an APA write-up. For our first hypothesis test, the following correlational test was conducted. Null hypothesis, there is no relationship between num cars and num defaults. The alternative hypothesis, there is a relationship between num cars and num defaults. The chi-square test and its p-value were calculated using PSPP assuming A equals 0.05. There was no relationship emerged. Formula, the chi-square presented 6 degrees of freedom. There were 150 cases. The statistic of the chi-square was 6.68 and the p-value 0.351. For our second hypothesis test, the following correlational test was conducted. Null hypothesis, there is no relationship between lick comfort and num defaults. The alternative hypothesis, there is a relationship between lick comfort and num defaults. The chi-square statistics and its p-value were calculated using PSPP assuming A equals 0.05, returned that there is no relationship that emerged. The formula states, then our chi-square, we had 6 degrees of freedom, 150 cases, the statistic of the chi-square 6.68, p-value equals 0.351. And in our third and final hypothesis test, the following correlational test was conducted. Null hypothesis, there is no relationship between num cars and leg comfort. The alternative hypothesis, there is a relationship between num cars and leg comfort. The chi-square statistic and its p-value were calculated using PSPP, assuming A equals 0.05. A relationship emerged. Formula result, the chi-square has 9 degrees of freedom with 150 cases. The statistic for the chi-square is 450. P-value equals 0.00, and the Kramer's V equals 1.00. Kramer's V indicated a very strong relationship. In this test, in order to determine that strong relationship, we'll look at our next slide, which is the Kramer's V interpretations. As you can see on this interpretations chart, if you follow the left column, and as the numbers grow, we find 1.00, and directly across from it, it tells us that it's perfectly symmetric. My takeaways from today's presentation: the chi-square is a significant test and should always be coupled with an appropriate strength test. Number 2, the chi-square can provide information not only on the significance of any observed differences, but also provides a detailed information on exactly which categories account for any differences found. Number 3, the degrees of freedom is equal to R minus 1 times C minus 1. That's row minus 1 times column minus 1, where R is the number of rows and C is the number of columns. Number 4, sample size matters. There are difficulties in interpreting when there are large numbers of categories, 20 or more, in the independent or dependent variables. And in closing, I want to thank everyone for participating in my presentation today, and I am available for any questions or further discussions via the CIU student portal. Thank you and have a good day.